What is a function in mathematics? So, a function is a relation between two variables x and y such that for each x there is exactly one y, or you could say that each x determines only one y. So here we shall call x as independent variable and we will call y as dependent variable. Also, x can be called an input variable and y could be called an output variable. So let's try to understand this concept of function using some examples. Let's look at example 1 and we will try to understand this concept through picture. Let's say we have x variable on this side and y variable on another side. You could think of x as chocolate bars, let's say, and y as the price of these chocolate bars. Let's say there is this chocolate bar A and it has a price $1. And maybe it also has the price $1.1. Let's check that if this description satisfies the definition of function or not. So function definition says that for each x there is exactly one y. In this case, one x value, which is a, it is associated with two y values. So the definition of the function violates here. So we will say that this picture does not represent a function. Moving on, let's look at another example. Here we have x and here we have y. We have, let's say, two chocolate bars A and B, and they have the price, both of these chocolate bars have the price $1. Now let's check that if the function definition holds or not. So each x should have one y, should determine one y. In this case, a determines one value, which is $1, and b also determines one value, which is $1. So the definition of function does not say that the y value should be unique. So as long as each x is associated with one y value, so the definition of the function holds. So in this case, yes, this is an example of this is the description of a function. This example 1 was not defining a function. Moving on, let's also look at the third example. We have x value, we have y on this side. Let's say we have three people, A, B, C, and they are associated with the number 16, which is their age, and C is associated with a number which is 17. So let's check that if this is the definition of a function, the definition of the function holds in this case or not. So the a value is associated with one y value, which is 16, b is also associated with one y value, which is 16, and c is also associated with one y value, which is 17. So the definition of the function again holds. But remember, we always talk about the function using the variables most of the time. So let's say we are defining a relation through this algebraic equation, and we have to test that if this relation is a function or not. First of all, since x is an independent variable, we take the values of x of our choice, and when we plug those values we get y values. In that way, y depends upon x, so we take some x values. Let's say we take 1, 2, and also -1. So the corresponding y values will be, for -1 you get 1, for 1 you get 1, and for 2 you get 4. So let's draw a picture. Here we are putting the x values -1, 1, and 2, and here we are putting y values, which is 1 and 4. So -1 and 1, both of these values are associated with y value 1, and 2 is associated with 4. Let's check that if this description holds for the definition of the function. So each x is associated with y, both -1 and 1, and both -1 and 1 are associated with 1, and 2 is associated with 4. So the definition of the function holds. So we'll say that yeah, this description is for the function, and this relation defines a function as well. Let's look at another example. We have a relation described through this algebraic equation, y is equal to plus minus square root x, and we want to again test that if this relation is a function or not. So we will take one x value, let's say 1, and this gives us y is equal to plus minus square root 1, which gives us plus minus 1. So let's try and see that if this is the description for a function or not. So we had taken one x value, which was 1, and the output was -1 and 1. So one x value is associated with two y values, -1 and 1, or we could say that one x value is determining two y values. So the definition of the function does not hold in this case, does not hold true in this case. So we will say that this description does not satisfy the definition of the function. So is this relation. So this relation is not a function.